Does anybody have homework questions? Well, we're still working on probability in Chapter 8. We're going to be looking at one of the stories your author put in Chapter 1. I don't know that any of you ever looked at these, but they're pretty fun. They're silly stories, each with a moral. They actually lead into our chapters in our textbook. So the Meanie Genie, I think that's a pretty good one. What I'm saying is you might want to read these. They're kind of fun. This one, students like this one a lot. This one is story 4. Before reading on, remember that truth is sometimes stranger than fiction. The highlight of Professor Berger's April 1993 talk to more than 300 Williams College students and their parents occurred when, after removing his shoes, he tied his feet together with a stout rope, leaped onto the table, dramatically removed his belt, unzipped his zipper, and dropped his pants. The purple cows, William mascots, mooing about on his baggy boxer shorts, completed an image not soon forgotten in the annals of mathematical talks. The more conservative parents in the audience were contemplating transferring their sons and daughters to a less progressive school. But then, at the moment of maximum shock and bewilderment, Professor Berger performed the seemingly impossible feat of rehabilitating his fast-sinking reputation. Without removing the rope attached to his feet, he turned his pants inside out and pulled his trousers back to their accustomed position, though now inside out. Thus, he simultaneously restored his modesty and his credibility by demonstrating the mathematical triumph of reversing his pants without removing the rope that was tying his feet together. So sometimes we look at these silly stories in the first week of class, but I didn't really want anyone demonstrating this in class, so I didn't bring this one up. But this is kind of fun to try in your dorm room. We did do the dodgeball in class, so that probably looks familiar. So these ideas lead into future chapters, and the one we're looking at here, the one with Professor Berger and the pants, that was one that led to topology. When we did the Mobius band, that was a chapter that we touched on topology a bit. Anyway, the Let's Make a Deal story has to do with probability. So let's go ahead. Do you remember The Price is Right? Anybody ever watch The Price is Right growing up? Right? Okay. Let's make a deal. Monty Hall enthuses to the gentleman dressed as a giant singing raisin. The gleeful raisin, whose name is Warren Peace, is ready to wheel and deal as Monty Hall explains the game. Behind one of these 3 doors is the Cadillac of your dreams. It is as long as a train and comes complete with a jacuzzi. Of course, if you spend too much time in the jacuzzi, your skin will wrinkle, but hey, you're a raisin. Your skin's already wrinkled. Monty Hall continues by warning that behind the other doors, however, are 2 other modes of transportation, 2 old pack mules. They don't come with jacuzzis, although given their exotic odor, you may want to give them a bath. Of course, the crowd is laughing and applauding, just as the studio sign instructs. I need one of those signs. Monty sums it up. So there are 3 closed doors. Behind one is a luxurious car, and behind the other 2 are mules. Now comes the moment of truth. What door do you pick? The audience erupts. Take door number 1. Take door number 1. Door number 2. Door 2. Door number 3 is the one. Poor Warren Peace looks around at the crowd, confused and nervous. He considers door number 1, then 2, then 3. Finally, Monty prompts, "Okay, Warren, which do you want?" The raisin-clad Warren shouts, Okay, I'll take door number 3. As Monty Hall quiets the overly excited audience, he tells Warren, "I'll tell you what I'm going to do. I'm going to show you what's behind one of the doors you didn't pick. Let's take a look behind door number 2. With that, Monty Hall turns to the Vanna White of the 1960s and says, "Please show us what's behind door number 2. The door dramatically swings open. The audience erupts, and Warren breathes once more. Behind door number 2 is a mule. Monty, knowing where the mules are, always opens one of the mule doors first. Okay, now here's the big question, right? Monty continues, we now see that the Cadillac is not behind door number 2. You guessed door number 3. I'll tell you what I'm going to do. If you want, I'll let you change your mind and choose door number 1 instead. It's up to you. Do you want to stick to your original choice, or do you want to switch? The audience goes nuts. Stick! Stick, yell half. Switch! Switch, advise the others. What to do? What to do? Stick or switch? That's what we're going to consider here in chapter 8.1. Should we stay or switch? Is one better? Are they the same probability? So let's go ahead and get some writing down, and we'll do an experiment to help decide should Warren switch his choice or should he stay? So we're in 8.1. We've been there a bit. We've been experimenting with some relative frequency experiments, and that's what we're going to do here. So here's the situation. We have 2 mules and 1 Cadillac behind 3 different doors. Okay? So Warren chooses a door. Monty opens a door, a different door, with a mule behind it. Okay? So Warren chooses a door. Monty opens a different door with a mule. And the question is, should Warren change his choice? Of door. Does it matter? Is he as likely to get the Cadillac either way if he stays or switches? Well, we're going to take out your deck of cards and experiment to see what's better. Okay, so we'll take out your deck of cards. Do you have your cards with you yet? You can use the, I don't know if you can use the card dealer on. I'll have to come around and share my cards with you, I think. I don't think it'll work to use a computer-generated one. Okay, so in your deck of cards, pick out an ace. That's going to be a Cadillac. And 2 twos. That can be the mules. Right? So we want the Cadillac. We don't want the mules. Everybody have their cards with them, right? You remember they're stuck in your backpack, I hope. Does anybody have cards with them? Here's what we're going to do. I'm going to come around and give you some to use. They might not be aces and 2s, but we'll get 3 cards for you. So here's how it's going to go. Okay, you're going to do this in pairs. One of you is going to be Monty, and one of you is going to be Warren. You can take turns, all right? So you're going to deal out the cards. Monty has to know what's under them, okay? Okay. Then whoever Warren picks one, and then Monty turns up a 2, right? Because Monty knows where the 2s are, because Monty looked. Warren stays with the first choice. And then record. Win or lose. Okay, so you're going to keep a tally. We're going to do experiment with relative frequency being pretty high here and see how likely Warren is to win if he stays and how likely Warren is to win if he switches. Because then, okay, do this 10 times. This time, same thing, except Warren switches. And then we do the same tally. Okay, we do that 10 times. So I'm going to come around and collect the data after you do this, and we're going to see if it's better to switch or stay. Before we play this, though, I want you to guess right up at the top here. Write your guess. So right here, okay? Write your guess. No change. No, doesn't matter. Warren should stay or Warren should switch. All right. Okay. All right. So I'll come around and make sure you're getting this figured out. I do want to remind you there is no study group Wednesday because there's no classes Wednesday. So our tutor decided to take that day off also. So get in groups of 2. If you have cards, that's great. Otherwise, I'll see what I can do here. Do you have cards? No. Okay. Do you understand how? No. Okay. So once you decide who's Monty and who's Warren, okay, and then I'll come back after you do the directions again and see if you get it. How many people are going to need a Warren?
I thought you did the same thing. I'm right.
Alright, who else needs a set? Need a set?
It doesn't matter.
Okay, you get the idea of how to charge it? Yeah. You do it 5 times? So you only need one for the 8 You need a person.
Wait, what am I supposed to
Who's
look
your card?
What am I supposed to look at? Yeah.
I'll come around.
Yeah.
So who are you playing?
And then you can.
Who are you playing? You're playing with your different people?
Yes.
I'm confused.
Oh,
Yeah.
That's it.
I don't
You don't know what you're doing?
No. Do I ever?
No.
Exactly.
How do you decide who's born here?
Wait.
Yay, Warren.
What am I supposed to be looking at now? This is why I don't play card games. I don't get it.
I know, but I'm the host.
All right.
One of you
Let's go.
I'm not gonna, I don't hear it, it's all of them, you have to know where the cards are.
Oh.
The big
Turn up
card.
the 2.
This one.
Okay, now we have to stay. No, we have to stay, right? We just stay here?
When you turn the one that doesn't.
If you stay, you win?
That's the.
No. Okay, so that's not.
I know which one's that.
Just one of the. Make sure somebody.
Why not? Basically, then I flip it 2 over and you.
Which one of you is Warren? You're Warren? And you're Monty? You're Monty?
Is Monty the slayer or the host?
The host.
She's the host.
Oh, you're the host?
Did you look up where the cards are?
Okay, so you know where the cards are. So you pick one.
Me?
Yeah, because you're the player now.
I am just so lost.
That's okay, we'll go through this together. Okay, so you're gonna pick that one?
Okay,
Okay, now,
I don't do
which
that.
one did you get? That one? Okay, don't, Okay, now you know, you know which ones are twos? Okay, turn up, not that one, but one of the ones that are twos.
Don't flip it over. I didn't. You flip up one that's not.
Okay, and now, did you win? Did Elena win? You picked that one, we saw you. You can pick it the other one. Okay, you lost. So put a mark on lose. Put a mark on lose. Did you write win and lose?
You go back to the middle.
And this is for Stan.
So for what?
This is for Warren stays, Elena stays with her first choice. So Elena stays with Sammy. We're gonna do that 10 times where she doesn't switch. And then, in the chord, win or lose. And then, after that, Elena's gonna change.
Second card.
Okay.
I'm gonna switch. Switch second round.
Okay, so now you can record. You got that?
I think so.
Okay, give it a try again. Anybody need help?
You have to look. You're the lowest.
I'm 50% right now. Yeah. Pretty good odds.
Yay! This is my first card. No.
Four more times.
And then flip it over. I don't know. I'm blocking.
Second card.
Wait. Mrs. Absent. Do we? After so I pick this one. Do we open this one first or another?
We're switching we're showing the whole game, so, she does turn up one, that's a 2, and then you decide, then you, see if you want to.
Okay.
Okay, so you're gonna sit here?
Yeah.
Good?
Right one?
Oh, I did.
Okay, write that down.
You sit in the middle one.
Okay. Shuffle it again.
Here you go.
You have to look. First card.
One more.
Okay. Then flip your cards. Oh, we won again. Heck yeah.
Okay, it's about a minute.
Shuffle the cards again.
First card.
It's the right, yeah.
First card. I won a second time.
I saw your name. Okay.
That's the first time I won.
Kind of weird. So the,
Oh, just two wins.
Oh, yeah.
Looks like you couldn't count either.
No, I cannot. I went to put it on before last day, but finished my education away paper every freshman. I'm happy for it. Two wins, two losses.
First card. Darn, I lost again.
Alright, so we're at 5 games right now. Alright.
We have a giant.
You lost again?
Yes. I'm terrible.
Well, at least you won some.
I don't like this game. I'm so good. Are you kidding me?
So you lost it.
Yes.
I'll save it for a day that I don't
They all look so much.
Yeah, pick this one, so you flip the two that I flip the two. And then now I have to work it out.
We gotta finish. We gotta finish. Pick one of these aces.
You're cheating. Yes. You keep bamboozling me.
Sorry, you didn't have mine.
Maybe you could have thought of that when you were drawing.
Alright.
Yeah.
So if your cards are marked, else more related. Okay, first choice.
I've got the snowy round. Oh, no.
Not cheating.
You didn't know it, so we were wrong.
You could have. You had something.
Yeah,
7 lines.
it's my turn. It's my turn now.
Okay, you did your 10 that way?
Yeah.
Okay, now you're gonna switch.
We're doing that right now.
Okay.
But our first round, she got 3 wins and 7 losses.
I'm horrible at this game, but
Okay. Alright, now let's see. So now you're gonna pick, you know which ones are the, you know, what's the thing.
I haven't looked yet.
There you go.
Oh yeah.
Okay.
Here were you? Yeah.
Okay, now you know which one.
Okay, now you can switch.
Because now you're switching. So that one you did. If you just stayed, you wouldn't want, you're not allowed to. So I wanted, no, you lost. But you would have.
This is not the
Okay.
So you have to switch on this one.
Yeah. Yeah, we did, I think.
You were close. Who's down there? I didn't get the numbers yet. No. Are you touching? Yeah. Oh, okay.
I didn't cheat.
Okay. So 3 wins and 7 losses.
You have to switch. Yep. No. This way. He was.
Yay, I did. Okay so far.
Switching.
5 and 5.
As you can probably tell, I'm awful at shuffling.
Uh-huh.
This. Hey, it's not like you were any better at playing me. Excuse me. Oh, why I don't do card games. I'm good at
So
them.
you've never gone for it?
I have, it's just I don't shuffle. I don't do things like poker and games and my I'm awful.
I'm the same. Oh my god, I never played that.
You did the same.
I haven't. I'm god awful at it. Okay.
Okay, who stated it? Yeah, yeah. Did I get one? You have at least.
You have to put this type for him. He lost.
Okay. You have
I
7 and 3.
I can't card game.
Switching, you have 4 and 6. Are those what I did?
Yeah.
Even though we do have some casinos in Wisconsin, I have no desire to go to them ever.
I'm probably never gonna go to a casino in my
No.
life. Honestly, it's like, it's gambles your money away. My grandma's
Why?
I've seen a lot, so. Okay, well, I take what you have.
First time I had 7 classes, 3 wins. So yeah.
And about 2 like
2 1 so far.
another one where your dad's up on the getting out.
Okay, now I just need, so we're seeing what is better. Should Warren stay or should Warren switch? Did you decide anything after playing this a little bit?
He should switch.
You should switch, you think? And yours should stay? Okay, well, let's put the data out. Okay, so row 1, add this up, please. Row 2, row 3, row 4. And check with the person next to you to double check your values, please.
I got you.
Two more? I think so.
There's only one more in here, right? Only one.
And then the final, right?
No, it was 3.
Is it really?
What did you get for row 1? Okay, what did we get for row 4?
31.
31? Everyone else get 31? Yeah? Do I see heads nodding? I don't see. Did anybody else check?
You have 30.
You got 31. All right. Everybody got 31. Row 3? 42. Thank you. Everybody else got 42. Right? Okay. Good. Row 2?
45.
Okay. Wonderful. Row 1?
35?
35.
He's a big brain.
So the total games that we played here were 80. So we had 35 out of 80 versus 45 out of 80.
.75% for the 35 out of 80 and then
Good.
45 out of 80. 56.2.
Okay. Now this one, we had a total of 73. So we had 42 out of 73 and 31 out of 73. So winning here, when you switch in, we see more probability of winning if our relative frequency is bearing out the probability, which I think we did enough games that is hinting toward that. The actual probability of winning, illustrated on my Excel note. Okay. So the actual probability of winning when you stay is 1/3. Our experiment came out to be 0.44, so not quite 0.33. The more experiments you do, the closer to the probability the relative frequency comes out to. So some of these games we had a lot of winning compared to losing, and some we had a lot of losing compared to winning. Because on every individual, we don't know what's going to happen, right? But the idea of probability is that we can take these ideas that maybe are different for each individual and come out with a good enough analysis that we can actually predict in a way that makes the casino profit or makes the insurance company profit. Okay, so this one, the actual probability when you switch is 2/3 that you'll win. So our experiment came out to 0.58, not quite 0.67. So that's kind of weird, isn't it, that you switch and you're more likely to win. In fact, twice as likely to win as if you stay. We're going to see why that is in section 8.2. So that's our next thing to go to, section 8.2. In our experiment, we got 0.44 compared to 0.58. So just to look at the difference between an experiment, well, maybe we'll wait and talk more about it when we get a little more information. So let's work in chapter 8.2 for a while, and then we'll talk more about relative frequency versus probability. So in 8.2, we look at definitions and can have reasons why things are working. 8.1 was to look at some kind of quirky instances of probability to hopefully make you interested in 8.2 and seeing why the numbers work the way they do. Now you'll probably have some familiarity with probability if you play any games. When you roll a pair of dice, for example, are you more likely to roll snake eyes, which is 2 1s, or a 7? Yeah, a 7. And how come? Yeah, higher probability, but why is it a higher probability? Does anybody know? We will know by the end of that 8.2. So in this section, the life lesson is to analyze simple things deeply. So that's what we'll focus on, analyzing simple things deeply. So let's start with tossing a coin. In fact, let's flip it 3 times. So at home, you can take a penny and flip it 3 times. I'm gonna give you a penny here if you don't have one to flip. If you have your, well, just use my pennies and then it's not, we can just collect them all at the end and I won't be collecting your money, okay?
What if you have your own?
So flip a coin. Okay.
I just like I can't flip the coin, that's why I just did it. I'm pretty good at it.
The kids are today.
Well, that was terrible.
Write down what you get. Okay, so I'll flip also. Okay, I got a head. Write down what you get. Another head. I got tails.
Some God-forsaken reasons.
Okay, let's write out the possible outcomes. I'm going to start with the one I had. Did anybody get a different order than heads, heads, tails? What did you get? Heads, tails, tails. Okay, what did you have?
I got all tails.
Tails, tails, tails. What did you have? All heads? Anybody have something that's not here? What do you have?
Tails had tail.
Okay, thank you. What do you have?
Tail, head.
Okay? Anybody have something different? What did you have? Heads, tail, heads. There's one more possibility. Does anybody have it? What did you have? Okay, thank you. Is one of these outcomes more likely than another? No, they're all equally likely, aren't they? So, what is the probability of getting 3 heads? So we haven't actually given a formal definition. If you just flip a coin once, what is the probability of getting a head?
1/2?
Yeah, 1/2, because there's 2 possibilities, and you could get either a head or a tail, but you want to know the probability of getting a head. So there's 1 out of 2 chances of getting a head if you just flip 1 coin. Now we see when you flip 3 coins, you have more, when you flip a coin 3 times, you have more than just 2 possibilities. You have all these 8 possibilities. So the probability of getting heads, heads, heads is 1 in 8. Because there's 8 possibilities altogether. And one of those has all heads. Let's see, what is the probability of getting 2 heads? Well, let's look at our list and see. So there's all the different possibilities that you had.
Oh, wait, never mind. There's more than one possibility.
Which ones have 2 heads?
The one with 3 heads?
Exactly. I should say exactly 2 heads. So we won't count the one with 3 heads. Which ones have 2 heads? Anybody else see 3 out of those possibilities?
I see the one with the three heads as a possibility, though.
So we're looking at exactly 2 heads, so not going to include the one with 3 heads. So I could have said, what is the probability of getting 2 heads and 1 tail would have been another way to describe what I'm trying to say. You just see 3? Okay. 3 is. What is the probability of getting 2 or more tails? What is the probability of getting 2 or more tails? Yeah, there's 4 out of 8. What is the probability of not getting any heads or any tails? What is the probability of not getting any heads or any tails? What would it be?
I wouldn't want to say that it's 0 because there's a possibility that the coin could land in its side.
So the possibility that the coin could land on its side. I feel like there was a movie where that kept happening. But we're going to say it's 0. We're going to say that if it lands on its side, we're going to bump the table, all right? So the probability is 0. What is the probability of getting a head or a tail. At least one head or at least one tail. Anybody? 8 out of 8, right? You get a head or a tail on any of these. 8 out of 8, which is 1. So probability falls between 0 and 1. Probability falls between 0 and 1 with unless you have an infinite space, the probability of getting 1 is certain, and the probability of getting 0 is impossible. Okay. So the actual definition of probability of the probability we should write down. The probability of the event E occurring is n divided by t, where n is the number of different outcomes in E. The number of different outcomes in E divided by the total number of equally likely outcomes. Oops. The probability of the event E occurring is n divided by t, where you have n is the number of different outcomes in the event, and t is the total number of equally likely outcomes. So that's why we needed equally likely outcomes when we were flipping 3 coins, and then we could pick out probability. We could pick out probability by counting. So there were 8 total number of equally likely outcomes, and then we could count out which one had 2 heads or which one had 2 or more tails, and just put that number on the top. This is your class activity for 8.2 rather. Where's my name placard? You can go ahead and put your name placard in there and take a picture. Okay, so we're on 8.2 now.
What is the class activity?
The definition of the probability of an event occurring. Now what we were trying to use was the law of large numbers in our experiments. So let's go ahead and write down what the law of large numbers is. The law of large numbers says if an experiment is repeated a large number of times, then the relative frequency of a particular outcome will tend to be close to the probability of that particular outcome. So if an experiment is repeated a large number of times, then the relative frequency of a particular outcome will tend to be close to the probability of that particular outcome. And so that's why we were using experiments in 8.1. We were looking for the law of large numbers to give us some hints about probability. So we experimented a large number of times with the Price is Right game, for example, to see if Warren should switch or stay, to give us an idea of what the probability, which is better. And it turned out that it is better to switch. We'll see why that probability is calculated later on. We'll take the number of different outcomes in the event and the total number of equally likely outcomes and calculate. You know, we might as well do that right now. We might as well look at the War and Peace scenario right now. The Price is Right. Okay, so we have the Price is Right scenario. Let's figure out the likelihood of winning if you keep the door. Okay, so Warren stays with his first choice. So let's write down the sample space just like we did with flipping coins. All right, so the sample space that we have, we could have behind each door, we could have a Cadillac or a mule. I'm going to write car. Okay, so you could have a car behind door 1, and then the mules would be behind doors 2 and 3. Or you could have the car behind door 2, and then the mules would be behind doors 1 and 3. Or you could have the car behind door 3, and then the mules would be behind doors 1 and 2. Okay, so here's how this starts out. These are the different possibilities. I can't remember which door Warren picks, but let's just say Warren picks door 2. Well, Monty changes it up a bit by opening a door that Warren didn't pick. That had a mule behind it. So in this case, Warren would have picked door 3. Monty would have opened door 2 because it had a mule, because Monty always knows where the mule is. Here, in this scenario, Monty would have opened door 1 because, again, Monty knows where the mule is. In this scenario, Monty could have opened either door, so I'll just cross out the mule in door 2. But Warren stays with his choice, so it doesn't really matter which one Monty opened. Warren stays with his choice. So now let's look. In this scenario, Monty opened door 2, but Warren still had picked door 3 and he stays there, so Warren loses. In this scenario, Warren also loses. In this scenario, Warren wins. So what are the odds of Warren winning then in the 3 scenarios? Just one, right? One chance of winning in the 3 scenarios. So the probability of winning is 1 in 3 because there's 3 different scenarios there, and in just one of them does does Warren win. Well, let's look at when Warren switches. So we have the same starting situation. Okay, we have the same starting situation. We have 3 doors. The car could be behind door 1, and then there would be mules behind the other 2 doors. The mule could be in the first door, and the car could be in the second, and the mule in the third. So that would be another situation. Or you could have the car behind door 3. So these are the 3 possible outcomes to begin with, and we'll still say Warren picks this at first. Okay, so Warren first picks door 3, and Monty, trying to make it nice for him, opens a door with a mule behind it. Okay, so I'm going to cross out the doors with the mules behind that Monty opens up. Now this time, Warren switches. Okay, so I'll put his switch choice. He only has one choice when he switches, right? There's only one. He has to switch either to here, or to here, or to here. So if he switches to door 1 there, he wins. If he switches to door 2 there, he wins. If he switches here, he loses. So he would have won, but then he loses. But that's still the probability of winning. Now there's 2 cases where the Warren could win out of 3. Would win in this case, and then lose in this case. So that's why it's better for Warren to switch. Okay, but don't tell the next 2 classes because they should be surprised, all right? We'll look more at probability on the Monday after Thanksgiving. Have a wonderful Thanksgiving. Thank you. Oh, thank you.